Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about Rolle's theorem.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, y equals x squared plus 4x plus 5 from the interval from -3 to -1, and we want to find the values of c that satisfy Rolle's theorem. Now, this function here, we know it's continuous from a to b, and it's differentiable on a to b as well. If I found this for you, f of -3 is equal to 2, and f of -1 is equal to 2 as well, when we plug those values into our function. Because we know all that, we can use Rolle's theorem here to find our value of c. So to do that first, we need to first find the derivative. So let's go find what f prime of x is here. Now we're going to use the power rule. 2 comes down, and 2x to the first power plus, well, just 4. Not too bad here. From there, we're applying Rolle's theorem. We can say f prime of x is equal to 0. We define that value. So we take 2x plus 4, set it equal to 0, and this is actually a pretty easy problem. Subtract 4 to both sides here. We have 2x equals a -4. Divide both sides by 2, and x equals a -2. And so our c value here is a -2, and that is the c value that satisfies Rolle's theorem. We're given this problem right here. Y equals x to the third power minus 2x squared minus x minus 1. And we want to find the value of c that satisfies Rolle's theorem on the interval from -1 to 2. Well, Rolle's theorem, to apply, we have to state that or find is fx continuous on a to b, and it is. Is it differentiable on a to b? It is. Then, and f of a equals f of b, and I found those values for you. F of -1 is equal to -3, as well as f of 2 is equal to -3 as well. Then it tells us there exists at least one c on our interval a to b, such that f prime of c equals 0. So let's go find that c value. Well, the first thing we need to do is find the derivative. So if we want to find f prime of x, let's call it. Power rule, 3 comes down, x squared minus 2 times 2 is a 4x, and then derivative of x is 1, so we have -1 here. Okay. With that, we need to set that equal to 0 to find the x value. So we take 3x squared minus 4x minus 1 equals 0. And this is where we actually have to use our good old quadratic formula. So x equals a -4 plus or minus the square root of -4 squared minus 4. A is 3, c is a -1, all over 2 times 3. Now hopefully you're pretty good with your quadratic formula, and you should get this. X equals a 2 plus or minus the square root of 7 over 3. So what this tells us here, these two values both end up being within our interval. It's important to check, and so our two c values here, we can write them separately as 2 square root of 7 over 3 and 2 minus square root of 7 over 3. And these are the two c values that satisfy Rolle's theorem. We're given this problem right here. Y equals a -x to the third power plus 2x squared plus x minus 6. And we want to find the values of c that satisfy Rolle's theorem from -1 to 2. Well, our function here is continuous on a to b, and it's differentiable on a to b. And I found f of a and b for you, and f of -1 is equal to -4, and f of a 2 is also a -4, so we're good on that front right there. So they tell us here with Rolle's theorem there exists at least one value of c on our interval that f prime of c is equal to 0. So let's go find that. First thing I want to do is find my derivative. F prime of x is just a bunch of power rule here. -3x squared, 2 times 2 is 4, plus 4x, then plus 1 here. Okay. So now from here we can take this and set it equal to 0 to find that c value. So -3x squared plus 4x plus 1 equals 0. We're solved. We're going to have to use our quadratic formula here. X equals negative our b value, which is 4, plus or minus the square root of 4 squared minus 4a is negative 3 times c is 1, all over 2 times a, negative 3. This simplifies to be a negative 4 plus or minus. The inside comes out to be a square root of 28 over 2 times negative 3 is negative 6. This simplifies out to b, and hopefully you know how to do this stuff, a 2 plus or minus the square root of 7 over a 3. And so our two c values here that satisfy Rolle's theorem, we can write them out separately, are 2 minus square root of 7 over 3 and 2 plus square root of 7 over 3. And both of these values actually do work because they're also both within our interval that was given. So again, our two values of c that satisfy Rolle's theorem are 2 minus square root of 7 over 3 and 2 plus square root of 7 over 3. We're given this problem right here. Y equals x to the third power minus 4x squared minus x plus 7. And we want to find the values of c that satisfies Rolle's theorem from negative 1 to positive 4. Now our function is continuous from a to b, and it's differentiable from a to b as well. I found f of negative 1 for you, and that is equal to 3, and f of 4 is also equal to 3 as well, so we're good on that front. So we now can apply Rolle's theorem. We have to first find f prime of x. So let's go find f prime of x, take the derivative here. 3 comes down, 3x squared now, minus 2 times 4 is 8, x to the first power minus a 1. And so we have our derivative here. We can apply Rolle's theorem by taking this derivative and setting it equal to 0. 3x squared minus 8x minus 1 equals 0, and we have to solve, well, for this x value. I have to use quadratic formula here. So x equals a negative b value, so it's a negative 8, plus or minus the square root of b squared, negative 8 squared, minus 4 times a, which is 3, times c, which is negative 1, all over 2 times a, which is 3. That simplifies out to be, partway, positive 8 plus or minus the square root of, 76 is inside the square root here, over 6. And this ends up simplifying out to be a 4 plus or minus square root of 19 over 3. And so both of these values are actually within our interval. We have to double check that, but they are, or I did, and letting you know. And so our c values here are, possible c values are 4 plus square root of 19 over 3 and 4 minus the square root of 19 over 3. And these two c values satisfy Rolle's theorem, and again, they're 4 plus square root of 19 over 3 and 4 minus the square root of 19 over 3. We're given this problem right here. Y equals a negative x to the third power plus 2x squared plus x minus 1. And we define the values of c that satisfy Rolle's theorem from negative 1 to 2. Now our function here is continuous on our interval from a to b, as well as differentiable on that same interval. F of a is equal to f of b is the other test, and I found that for you here. F of negative 1 is equal to a positive 1, and then f of 2 is also equal to positive 1, and so we're good there. Now from here, to apply Rolle's theorem, we first need to find the derivative. So f prime of x here is equal to 3 comes down, negative 3x squared plus 2 times 2 is a 4, 4x, derivative of x is a 1. So now to apply Rolle's theorem, we set this equal to 0 and solve. Negative 3x squared plus 4x plus 1 equals 0, and we apply the quadratic formula here. X equals a negative b value, which is 4, plus or minus the square root of 4 squared minus 4 times a, which is negative 3, times c, which is 1, all over 2 times a, 2 times negative 3. Simplify this part way down. X equals a negative 4 plus or minus the square root inside here is a 28 over 2 times negative 3, which is a negative 6. This breaks down to be, hopefully you can practice this and know it, a positive 2 plus or minus square root of 7 over 3. And so both of these values are actually within our interval -1 to 2. And so we can say that our two c values are 2 minus square root of 7 over 3 and 2 plus square root of 7 over 3. And so those are the two c values that satisfy Rolle's theorem. We're given this problem right here. Y equals x to the third power minus x squared minus 4x plus 3. And we need to find the values of c that satisfy Rolle's theorem from -2 to +2. Now to satisfy Rolle's theorem, we need to find where is a question, f of x continuous on a to b, which it is, differentiable on a to b, which it is. We have to find if f of a is equal to f of b, and I got that for you. F of -2 is equal to -1, and f of +2 is also equal to 1, so we're good there. So let's go apply Rolle's theorem. We first need to take the derivative, so f prime of x is equal to 3x squared minus 2x minus 4. And once we have that derivative right there, we have to set it equal to 0 and solve. So we have a 3x squared minus 2x minus 4 equal to 0. And hopefully you remember the quadratic formula here. X is equal to a negative, our b value, which is -2, plus or minus the square root of our b value, -2. I wrote a 3 there. Minus 2 squared minus 4 times a, which is 3. C is -4. All over 2 times a, which is 3. This simplifies out to be x equals a +2 plus or minus the square root. This inside's a 52 over 6. This simplifies to be 2 plus or minus 2 square root of 13. That's what's inside the square root of 52 is 2 square root of 13 over 6, which simplifies, hopefully you know how to do that, 1 plus or minus square root of 13 over 3. And so our two c values here, or these two c values we check, they're both within our interval from -2 to +2, so we're good there. And so our c values, write them separately, is 1 plus square root of 13 over 3, and 1 minus square root of 13 over 3. And these are the two c values that satisfy Rolle's theorem. We're given this problem right here. Y equals a negative x squared minus 2x plus 15 over a negative x plus 4. And we have to find the values of c that satisfy Rolle's theorem, and those over the interval -5 to 3. Now, is our function continuous from a to b? Yes, it is. Is it differentiable on a to b? Yes, it is. Okay, so our function is differentiable and continuous on that interval. Our f of -5, I found it for you, is a 0, and f of a 3 is also equal to a 0. Okay, the only value that would cause an issue here is putting a 4 in the denominator, right? It causes divided by 0, but that's outside of our interval, so we're good for the continuous and differentiation part. So we can satisfy Rolle's theorem here. We need to now find the derivative. F prime of x, let's use our good old quotient rule here, derivative of the top. We have a -2x minus 2 times the bottom, -x plus 4, minus derivative of the denominator, -1 times the top part, -x squared minus 2x plus 15, all over the denominator squared, -x plus 4 squared. Now from here, we're going to simplify this out here. Let's go FOIL this first part. -2x times x, we have a positive 2x squared. -2 times x times 4 is a -8x. Multiply that out, positive 2x here, and a -8 going on there. These negatives cancel to be positive, so we just have a minus x squared minus 2x plus 15. All over here, a good old -x plus 4 squared. Just double checking so far, and we're good on my steps here. From there, we need to simplify, combine the like terms. 2x squared minus an x squared is just an x squared. The 2x, got them, the 2x and the 2x cancel, we're good there. We just bring down the -8x, got that. And then -8 and 15, oh, come out to be a positive 7. And we got them all. And we're divided by still this -x plus 4 squared. And that's our f prime of x. Well, this simplifies out a little more. We can factor the numerator, and it's an x minus 1 times an x minus 7 here, over their denominator, a negative x plus 4 squared. And now what's great here about our rational functions, we have to set it equal to 0. We're going to solve that. So we have an x minus 1, an x minus 7, over a negative x plus 4 squared. And when we set that equal to 0, what we really care about is just the numerator. The denominator, not really dealing with, is just the numerator when it's equal to 0. So we can set both of them equal to 0, x minus 1 equals 0, x minus 7 equal to 0, and solve that x equals a negative 1 and x equals a positive 7. Now notice here that 7 is outside of our interval that was given to us. It wasn't asked of us, so we don't use it. So negative 1 is the only value within our interval here. Oh, sorry, a positive 1. I can't add. A positive 1 there. And so c equals a positive 1 is the only c value that satisfies Rolle's theorem. We're given this problem right here. Y equals x squared minus 2x minus 15 over a negative x plus 6. And we want to find the values of c that satisfy Rolle's theorem on our interval from negative 3 to positive 5. Now, luckily for us, our function is continuous on a to b. The only issue that we would have is when x is 6 here, because the denominator would equal 0, but it's outside the interval. Same thing with it being differentiable. Same issue, but we're fine there. If f of a is equal to f of b, we're good, and I found them for you. F of negative 3 is equal to 0, and f of positive 5 is also equal to 0. From there, we can apply Rolle's theorem. We need to take the derivative. So f prime of x, using the quotient rule here, derivative of the numerator, 2x minus 2 here is the derivative of the numerator, multiplied by the denominator, negative x plus 6, minus derivative of the denominator, negative 1, times the numerator, x squared minus 2x minus 15. All over a good old denominator squared, negative x plus 6, all squared. From there, let's go simplify what we can. We're going to be multiplying things out here. Multiply these together. 2x times negative x is a negative 2x squared. 2x times 6 is a 12x. Negative 2 times x is a positive 2x. And negative 2 times 6 is a negative 12. These negatives cancel to be a positive, and so we just have a plus a x squared minus 2x minus 15. All of that is good over the good old negative x plus 6 squared. From there, let's combine our like terms. So many steps here, but it's be worth it. Negative 2x squared plus an x squared is a negative 1x squared. Got them covered. The 2x and the negative 2x cancels each other out, so we just have a plus a 12x here. Got that down. And then negative 12 minus 15 is a negative 27. All of that over this negative x plus 6 all squared. Keep on going. I pulled out a negative in the numerator, so we have a negative out here. X squared minus, if I can do my math, minus 12x plus 27 over a denominator, which is the negative x plus 6 all squared. Keep on going, and that does factor out, and we have that factoring to be an x minus 9 times an x minus 3 over a negative x plus 6 all squared. Now Rolle's theorem states once we have a derivative, we have to set it equal to 0, so let's go do that. And we define the c values with x values here. Now we only really care about our numerator. Our denominator really just causes anything to be undefined, so the numerator, we define when that is equal to 0, and then we're good. So we take our numerator, our negative x minus 9 times an x minus 3, set it equal to 0. Divide both sides by a negative, doesn't really matter, because 0 is over there. We set both parts equal to 0. X minus 9 equals 0, x minus 3 equals 0. And so we have x equals 9 and x equals 3. Now, be careful here, x equals 9 is not within my interval, so we don't count that one. 3 is the only one within the interval, so a c value of 3 is the value of c that satisfies Rolle's theorem here. We're given this problem right here, y equals a negative x squared plus 2x plus 15 over an x plus 4, and we have to find the values of c that satisfy Rolle's theorem on our interval from negative 3 to 5. Well, does our function satisfy Rolle's theorem? Is it continuous on a to b? And it is. The only issue we would have is when x equals 4, right, or negative 4, dividing by 0 in our denominator, but it's outside our interval. Same thing with differentiable, we're good there. F of a is equal to f of b? Well, I found that for you, and f of negative 3 is equal to 0, and f of 5 is also equal to 0. So you're good there. So we now can apply Rolle's theorem. So we first need to find our derivative. F prime of x is equal to the derivative of the numerator, so that's a negative 2x plus 2, times the denominator, an x plus 4, minus the derivative of the denominator, which is just a 1, times the numerator, a negative x squared plus 2x plus 15. All of that is good all over x plus 4 squared. So from here, we need to simplify this out a little bit. F prime of x is equal to, let's multiply it out, negative 2x times x is negative 2x squared. Negative 2x times 4 is a negative 8x, 2 times x is a 2x, and 2 times a 4 is an 8. So far, so good, right, with my notes? And we're good. The negative times 1 doesn't really matter here with the 1, so negative, we basically change the signs here, going across, distributing throughout. We have positive x squared, a minus 2x, and a minus 15. I got them all there. Denominator stays the same, x plus 4, all squared. Well, let's combine our like terms where we can in the numerator, so f prime of x is equal to, we have negative 2x squared and x squared is just a negative x squared. We got them. The 2x and negative 2x cancels, and so we're left with just a minus 8x here. Got that. And then 8 minus a 15 comes out to be a negative 7. Cancel that out. All over our denominator, x plus 4 squared. Now from here, I like to pull out a negative in my numerator before I try to factor this. So a negative comes out, and I have an x squared plus an 8x plus a 7 over an x plus 4, all square. And now the numerator, it's a little easier to see how it factors. We have a negative, it's an x plus 7 times an x plus 1, all over that x plus 4 squared. All right, so Rolle's theorem here, once we found a derivative, we want to have it equal to 0, and we're going to solve for our x values, which is our c values here. Now, to do that, though, we only really care about the numerator of a rational function. The denominator, if it equals 0, it's undefined there. For the numerator, we can do that. So we take our numerator, negative x plus 7 times an x plus 1, and set it equal to 0. Now the negatives I don't really worry about, because if I divide by negative 1 to both sides, it kind of eliminates because 0 doesn't really do anything. So now we can set each one in parentheses equal to 0. We have an x plus 7 equals 0, and x plus 1 equal to 0. Subtract 7 on both sides, and x equals a negative 7. If I can write negative 7. The same thing with the 1 equals a negative 1. Now with that, negative 7 is not within my original interval. Cancel that out. And so negative 1 is the only value within our interval. And so our c value is equal to negative 1, and that is the only c value that satisfies Rolle's theorem. We're given this problem right here. Y equals x squared plus x minus 6 over a negative x plus 3, and we want to find the values of c that satisfy Rolle's theorem on our interval from negative 3 to positive 2. Now, Rolle's theorem tells us we can only do it when our function is continuous from a to b. And our function is continuous in a to b except for when x is equal to, well, 3. Notice 3 in the denominator causes that to be dividing by 0. So we're good there. Same thing where it's differentiable, we're good for the same reason. F of a has to equal f of b, and I found that for you. F of negative 3 does equal 0, and f of 2 also equals 0. So we're good there. So we now can apply Rolle's theorem. So we first need to find our derivative. F prime of x is equal to The derivative of the numerator using the quotient rule is a 2x plus 1 times the denominator, negative x plus 3, subtracted by the derivative of the denominator, negative 1, times the numerator, which is x squared plus x minus 6, all over the denominator, negative x plus 3 squared. From there, we need to keep simplifying. F prime of x here is equal to, well, let's multiply this out. 2x times a negative x is a negative 2x. 2x times 3 is a 6x. 1 times a negative x is a negative x. And 1 times a 3 is a 3. The negative 1 cancels to be a positive 1. So we just add an x squared plus x minus 6 here. All over denominator, negative x plus 3 all squared. Now from here, we need to combine, 2x squared, I almost forgot that. If you noticed that, let me know down in the comment section below. F prime of x now is equal to, combine our like terms, negative 2x squared and x squared is a negative 1x squared. Got them. Negative x and positive x cancel, and so we just have a plus a 6x here. Got that down. And 3 minus 6 is a negative 3. All that is over a negative x plus 3 all squared. Now, this actually can't really simplify any more. What we're looking for here is we want to find where it's equal to 0. Now, we only really care about is the numerator here. The denominator equaling 0 just causes it to be undefined. So we want to find when the numerator is equal to 0 here, which will be, well, 0 over anything is going to be 0, right? So we take that negative x squared plus 6x minus 3, set it equal to 0, and I'm actually going to divide both sides by a negative 1 to get an x squared minus 6x plus 3 equals 0. And I find this a little easier to deal with. With that, this doesn't really factor at all, so we have to use a quadratic formula. X is equal to a negative b value, which is negative 6, plus or minus the square root of b squared, negative 6 squared minus 4 times a, which is a 1, times c, which is a positive 3. I can write 3, all over 2 times a, which is 1. Now, I simplified this whole thing for you, and I simplified the whole thing, and we have an x equals 3 minus square root of 6, and 3 plus a square root of a 6. Just making sure I have all my steps here correctly. It's a positive 3. We're good there. All right. So with that, only one of these values is within our interval, and that is the first one, the 3 minus square root of 6. This 3 plus square root of 6 is outside the interval, clearly, and so our c value here is a 3 minus square root of 6, and that is the c value that satisfies Rolle's theorem. We're given this problem right here, y equals a negative 2 sine of 2x, and we need to find the values of c that satisfy Rolle's theorem on our interval from negative pi to pi. Now, Rolle's theorem says we define it for functions continuous from a to b, which it is, as well as differentiable on a to b. F of a has to equal f of b, and I found that for you, and f of negative pi is equal to 0, and f of pi is also equal to 0. So we're good there. So now we need to find the derivative of our function. F prime of x here is a negative 2, derivative sign is cosine of 2x, multiplied by the derivative inside, which is 2. Simplify this out, and f prime of x is equal to negative 2 times 2 is a negative 4 cosine of 2x. Pretty simple. Now, to apply Rolle's theorem, we take this derivative and equal 0. Negative 4 cosine of 2x equals 0. We're solving for x. Divide both sides by negative 4, and cosine of 2x is equal to 0. So when does when is x equal 0? Or when does cosine of 2x equal 0? What are the x values? Well, this occurs when x is equal to a pi over 2 times n, or pi n over 2 minus a pi over 4. And the only x values that work here within our interval are negative 3 pi over 4, negative pi over 4, pi over 4, and 3 pi over 4. And so these are the c values here that satisfy Rolle's theorem for our function. I'm given this problem right here, y equals sine of 2x, and we define the values of c that satisfy Rolle's theorem on our interval from negative pi to pi. Now, luckily for us, our function is continuous from negative pi to pi and differentiable from negative pi to pi. We want to find f of a negative pi, and I found that for you, and that's a 0, as well as f of pi is also equal to 0. From there, we want to find the derivative to apply Rolle's theorem. So our derivative here, f prime of x, is equal to derivative sine is cosine of 2x times the derivative inside, which is 2. We can rewrite that to be f prime of x is equal to 2 cosine is right out front of 2x. Now to apply Rolle's theorem, we need to set this equal to 0. So we take a 2 cosine of 2x and set it equal to 0. Divide both sides by 2, just kind of limit it to 2. Cosine of 2x is equal to 0. Now when does this happen? When does cosine of 2x equal to 0? And that occurs when x is equal to pi times n over 2 minus a pi over 4. And so the values of x that are within our interval of that for different n values are negative 3 pi over 4, negative pi over 4, pi over 4, and 3 pi over 4. And so these values are the c values here of our function that satisfy Rolle's theorem. We're given this problem right here, y equals x squared minus x minus 12 divided by x plus 4, and we define the values of c that satisfy Rolle's theorem on our interval from negative 3 to 4. Well, the first thing I find, can we apply Rolle's theorem? Now, our function is a rational function, and the only place where it doesn't exist here is at a negative 4, because we would divide it by 0. Everywhere else it exists, it's also continuous everywhere else, and it's differentiable everywhere else. And so we're good there within our interval, because negative 4 is outside of the interval. I found for you f of negative 3, which is 0, and f of a positive 4, which is also equal to 0, so we're good on this last part there. Since we satisfy all of our conditions, we can apply Rolle's theorem. We need to take the derivative. So what is f prime of x here? Well, using quotient rule, we find the derivative of the numerator, which is a 2x minus 1, multiplied by our denominator, an x plus 4, subtracted by derivative of the denominator, which is a 1, times the numerator, which is an x squared minus x minus 12, all over an x plus 4, the denominator squared. To simplify this bad boy out, f prime of x is equal to 2x times x is a 2x squared. 2x times 4 is an 8x. Negative 1 times x is a negative x. Negative 1 times 4 is a negative 4. Minus, bring the minus sign over, minus x squared plus x, don't forget it, and then plus a 12. All over a good old x plus 4 all squared. From there, we can simplify our numerator. 2x squared minus 1x squared is a single x squared. We got them. The negative x and positive x cancel, so we just bring down this 8x right here. And then minus 4 and 12 is a positive 8 as well. Divided by an x plus 4 all squared. Okay. Well, this function can't really simplify anymore. All right. And so what we want to do is find where it's equal to 0. Right. That's the whole point using Rolle's theorem. Now, we only really care about our numerator here. If we're dividing by 0, it's undefined. But if the numerator is equal to 0, then the whole thing's equal to 0. So what do? We take that numerator. Let's do it over here. Make sure I have enough room for what I'm doing. We take that numerator, I'll do it right here first, x squared plus 8x plus 8, and we set it equal to 0. And we're solving the values of x here. Now with that, we need to use the quadratic formula. So x equals a negative b value 8 plus or minus the square root of 8 squared minus 4 times our a value, which is 1, our c value is 8. All over 2 times a, which is 1. From there, we can simplify this, and this actually simplifies. I've done it for you. X equals a plus or minus, oh sorry, 4, negative 4, oh my goodness, I'm skipping things. Negative 4 plus or minus 2 square root of 2, and that's what it simplifies to be. Now, let's go write it actually like this, plus and minus 4 minus 2 square root of 2. So these are our two values here, two options. Well, the second one is outside of our interval, so we can't actually use it. We can only use the first one here because it's out. The second one was outside of this value here. The first one, we were fine. And so our c value that satisfies this is a negative 4 plus 2 square root of 2, if I can write that. Oof. Anyway, the c value here that satisfies Rolle's theorem is negative 4 plus 2 square root of 2, and that is our final answer. We're given this problem right here. Y equals a negative x squared minus 2x plus 8 divided by a negative x plus 3. And we define the values of c that satisfy Rolle's theorem from our interval from negative 4 to 2. Now, first we're going to see, does this actually work with Rolle's theorem? Is our function continuous? The answer is, well, yes, on our interval. If we put a 3 in for x here, we're dividing by a 0, and that's the only place that it wouldn't work, being a rational function, but it's outside our interval. Same reason for, or where it's differentiable. We're fine there unless it's positive 3, but it's outside of our interval, so we're good. What about f of a equal to f of b? I found those values for you, and f of negative 4 is equal to 0, and f of positive 2 is also equal to 0. So now we can apply Rolle's theorem. We first need to find the derivative. F prime of x, let's use the quotient rule here. Derivative of the numerator is a negative 2x minus 2 times our denominator, negative x plus 3, minus the derivative of the denominator, which is a negative 1, times the numerator, negative x squared minus 2x plus 8. All over our denominator, negative x plus 3, all squared. So then from here, we need to, well, simplify this. F prime of x is equal to, multiply this out, negative 2x times a negative x is a positive 2x squared. Negative 2x plus times 3 is a negative 6x. Negative 2 times a negative x is a positive 2x. And negative 2 times 3 is a negative 6. Now the double negatives here cancel out to be positive, so we just bring down the negative x squared minus 2x plus 8. Just double checking I did all that right. Didn't forget a minus sign because that would ruin this whole problem here, and I think we're good. All over our denominator, which is a negative x plus 3 squared. So let's go simplify this numerator out. Well, 2x squared minus an x squared is a positive 1x squared. We got them. The 2x and the minus 2x cancel, so we just bring down the minus 6x right there. Got that. And negative 6 plus 8 is a positive 2. All of that is over our negative x plus 3 all squared. Okay, so we've basically simplified this derivative all the way, and we need to find where it's equal to 0 to apply Rolle's theorem. Well, since it's a rational function, we only really care about the numerator. That's where it's equal to 0. The denominator, if it's equal to 0, it's undefined. So we kind of ignore that, and we take the numerator of x squared minus 6x plus 2. We find where that's equal to 0. Now, hopefully you remember the quadratic formula. X equals a negative b value, which is also a negative 6, plus or minus the square root of negative 6 squared minus 4 times our a value, which is 1, and our c value, which is 2, all over 2 times our a value, which is 1. Now, luckily for you, I solved this, but you should know the quadratic formula here, and that is a 3 minus square root of 7, and a 3 plus the square root of 7. The 3 plus square root of 7 is outside of our interval that we were looking at, so we don't use that one, and we can only use the first one because it's within our interval. So our c value is equal to 3 minus square root of 7, and that is the c value here that satisfies our theorem. We're given this problem right here. Y equals a negative x squared plus 36 over an x plus 7, and we need to find the values of c that satisfy Rolle's theorem on our interval from -6 to +6. Now, this is a rational function, and so it's not continuous when we're dividing by 0. And the only place that happens is -7. So we're going through our conditions of Rolle's theorem, and if x is -7, we're dividing by 0, we can't do that, but it's outside our interval. Same thing where it's differentiable. -7, sure, outside the interval, we're good. But what about f of -6? Is it equal to f of +6? And I found these values for you, and f of -6 is equal to 0, and f of +6 is also equal to 0. So we're good there. All right, we now need to find our derivative. F prime of x is equal to the derivative of the numerator, which is a -2x, times the denominator, x plus 7, minus derivative of the denominator, which is a 1, times the numerator, -x² plus 36. All over our denominator, x plus 7 squared. Simplify where we can. F prime of x now is equal to, multiply this out, -2x times x is a -2x squared, and -2x times 7 is a -14x. Subtract that by, well, one don't want to really worry about, and let's distribute that minus sign, so we have plus an x squared minus a 36 all over an x plus 7 all squared. Okay, so now let's go simplify what we can in our numerator. Combine our like terms. F prime of x is equal to, well, -2x squared plus x squared is a -x squared. Got that right there. Use them. No other x's, so minus 14x here. And then minus 36 all over our x plus 7 all squared. From there, all right, we need to find where this is equal to 0 to apply Rolle's theorem. There's nowhere else really I can simplify this. Now, to do that, since this is a rational function, we just need to take our numerator and set it equal to 0. Because if the numerator is equal to 0, we're dividing by anything, it's still 0, right? And denominator, if it equals 0, undefined. So we take that -x squared minus 14x minus 36 and set it equal to 0 there, okay? So with that, now let's use our quadratic formula, okay? We have x equals a negative b, so a negative, our b value is -14 here, plus or minus the square root of our -14 squared minus 4 times a value, which is -1, times c, which is -36, all over 2 times a, which is a -1. Now, luckily for you, I solved this for you. This simplifies to be a -7 plus square root of 13, and a -7 minus the square root of 13. Now, -7 minus square root of 13 is outside of our interval. We don't use that. So we can only use the c value here, of the x value we found. It's a c value of -7 plus square root of 13. And this is the only value of c that satisfies Rolle's theorem of our function. We're given this problem right here. Y equals a -x squared plus 4 divided by 4x, and we define the values of c that satisfy Rolle's theorem on the interval from -2 to +2. Now, to use Rolle's theorem, we have some conditions. Our first one is our function continuous from a to b? Now we look at our function and it's a rational function. We're dividing by 4x. And if I put a 0 in for x, our denominator is equal to 0, and we're dividing by 0. And so it doesn't exist there, and it's not continuous there. So at x equals 0, our denominator is equal to 0. But there's an issue. If x equals 0 causes our function not to be continuous there, at x equals 0, that is within our interval. And so right from the get-go, our function is not continuous on our interval, and so Rolle's theorem cannot be applied. So the function is not continuous on -2 to +2, and having x equals 0, and that's our final answer. That's the reason why we cannot use Rolle's theorem to find the value of c. So again, our final answer here is the function is not continuous on -2 to +2. We're given this problem right here. Y equals 2 times the tangent of x, and we're going to determine if Rolle's theorem can be applied and what are the values of c that satisfy this theorem from negative pi to positive pi. Now the first part of Rolle's theorem here, we want to determine if our function is continuous on our interval. And this is where the hiccup actually happens. We know tangent of x has vertical asymptotes, and that happens within our interval at x equals a negative pi over 2 and a pi over 2. And again, that's within the interval. But we found two places here where we have a vertical asymptote and our function doesn't exist there, and therefore it's not continuous there. And so these two values, x equals negative pi over 2 and pi over 2, is where it's not continuous. So we can't apply Rolle's theorem. So we write here is the function is not continuous on negative pi over pi, from negative pi to pi. And that's why we can't apply Rolle's theorem, because our first rule says it has to be continuous, and once we've hit a roadblock there, it's not continuous there, we're basically done. So again, our final answer is we cannot apply Rolle's theorem because the function is not continuous on our interval from negative pi to positive pi. We're given this problem right here, y equals a negative 2 cosine of 2x, and we want to find the values of c that satisfy this theorem on our interval from negative pi to positive pi. Well, luckily for us, our function is continuous on our interval as well as differentiable on our interval. And I found our f of a and f of b. F of negative pi is equal to a negative 2, and f of pi is also equal to a negative 2. So we satisfy all of our rules for Rolle's theorem, and so let's go find it. Let's find the values of c. First thing I want to do is find my derivative, f prime of x. Negative 2 comes down here, and the derivative of cosine is a negative sign. So we have a negative sign of 2x, if I write x here, there we go, x, times the derivative of the inside, which is a 2. If we multiply all that out, f prime of x, negative 2 times a negative is a positive 4. Don't forget that double negative, so positive 4 sine of 2x here. Now, Rolle's theorem states we have to set it equal to 0 and solve for x. So we take 4 sine of 2x and set it equal to 0. Divide both sides by 4 and sine of 2x is equal to 0. So where does this occur? When is the sine of 2x equal to 0? Well, that occurs when x is equal to pi times n over 2. And so the values here that work, because remember it keeps going over and over, it's periodic, the values that work within our interval here are from as negative pi over 2, 0, and pi over 2. And those are the values of x that work within our interval here that makes sine of 2x equal to 0, and so we call those our c values. So the c values that satisfy our theorem are negative pi over 2, 0, and pi over 2. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math, when you need help you use Minute Math.